Good evening, everyone, and welcome to the third of our webinars. These webinars are jointly hosted by AFBI, AgriSearch, and the Ulster Farmers Union. My name is William Irvine, one of the deputy presidents within the union, and I'm chairing tonight's session. So, some housekeeping details just before we move on into the webinar in earnest. As you just heard, this evening's webinar will be recorded and the link will be sent out post the event so it can be watched at a later date if wished. Any questions are entered through the Q&A button at the bottom of your screen if you're using an iPad, or it may be at the top of the screen on your phone. At the end of the night's session, there's a survey, and we would encourage you to complete that survey so that we can continually improve what we're doing here. So the first speaker is Professor Elizabeth Magowan, and she's going to introduce tonight's topic and the speakers for this evening. Elizabeth.
Thank you very much, William. And hopefully folk can start to see my slides there. If you could just give me a nod, William, if you can see them coming up.
That's good.
Great, thank you. So good evening, everybody, and thank you for letting us into your living rooms and kitchens this evening again. I'm just going to take a couple of minutes to explain why we have undertaken this series of webinars. And basically the story here is, and hopefully you're not getting too tired of Grandpa Joe here, but back in the day, farming was quite different, and it was less intensive. There was a big drive to produce healthy food, and indeed, it could be argued that back, in the 20s, 30s, 40s, 1920s, 30s, 40s, there was good biodiversity on farms, and soil health was better than what we have today. But as time has moved on, and the family, Senior Joe has come on board, there's a few more pressures on the farm, and farming has become more intensive over the 70s, 80s and 90s. And indeed, into those periods of years, we've begun to realise that we need to control the amount of nitrates and phosphates coming off the land, and legislation was put in place to do that. But going forward, the younger generation of our day is going to have even more challenges and different challenges than what we had in the past. And it's for that reason these webinars have been set up. So, Josie here, young Josie's going to take over the farm someday, and going forward, that farm is going to have to continue to produce good, wholesome, healthy food for a growing population. And but in doing so, very much has to protect the environment going forward and minimise the amount of nitrates and phosphates coming off the farm. Going to have to improve soil health back to the good old days, if you like, enhance biodiversity on our farms. And now ahead of us is very much the need to reduce ammonia emissions, as well as those greenhouse gases of methane and nitrous oxide. So there's lots of scientists working very, very hard, both in AFBI, Queen's, UCD, Chuggas, loads of organisations locally, nationally and internationally on lots of solutions to support the farming industry in reducing their environmental impact. But there are lots of things that farmers can do right now as well to help. And I was fortunate enough to lead a consortium of folk across the UK to produce what we called the Net Zero Livestock Report, how farmers can reduce emissions using tools that they currently have. So if you're interested, you could see that report on the CL Livestock website. But as I say, those actions really fall into a number of areas. And a couple of weeks ago, we had our first webinar on increasing production efficiency, but in such a way that it benefited the environment as well. So that you can watch that back. Last week then, David Patterson gave us a talk on, again, resilient grassland management, and there was a lot of discussion there around the use of clovers and legumes, and even, the incorporation of agroforestry and forestry into the farmland. Tonight, we're focusing on dairy nutrition, and I'm delighted that Anna Lavery, in conjunction with Amy Louise Craig, will present. Anna's presenting tonight on a lot of interventions to reduce nitrogen and phosphorus excretion from dairy cows through dietary manipulation. And then Omar, Cristobal, Carballo will also present to us on a lot of the work that's going on at Hillsborough to reduce methane emissions. Next week, then, we will be talking about nutrient management in grasslands, and in the fifth webinar, we'll be summing up with some farm case studies. So with no further ado, as I say, we're trying to give you tools and solutions that you can adopt today that will both improve productivity, profitability on farm, but also reduce your environmental impact. So Anna, over to you for the start of nitrogen and phosphorus in dairy production. Thank you.
Great, thanks, Elizabeth. If I just get these slides. Okay, if someone can give me a nod if they can see that.
Yep. You're good, Anna, you're good.
Great, thank you. Okay, so good evening, everyone. I'm going to chat through improving the sustainability of Northern Ireland dairy systems with regards to dairy nutrition. And I want to acknowledge my colleague Amy Craig, who also contributed to this presentation. So the increase in productivity in the industry over the last number of years has been driven primarily from concentrate use, but with that comes a number of challenges. So of course there's an economic impact, so concentrates are the most expensive component of the diet, and with volatility in ingredient prices, it can be difficult to manage. There's also the local environmental challenges, in particular phosphorus and nitrogen, which I'll cover in the next few slides. There's also the sustainability issue. So, with human edible food being used in feed for animals, and with an increasing global population, global food security is a major challenge. Also, the sustainability of production. So, there is a move to secure more locally grown proteins in Northern Ireland and within Europe. But there's also a move to include more byproducts, so byproducts from the oil or brewery industry. And it's this whole idea of circularity. And in the last few years, supply chain issues have come to the fore, whether that be a result of extreme weather events impacting harvests, or events such as the war in Ukraine, which has impacted cereal production and harvests. So these are all challenges we are faced with when relying on the use of concentrates for milk production. So firstly, if we look at this from an environmental standpoint, I don't need to highlight the current blue-green algae issues in Northern Ireland's waterways, but eutrophication is a consequence of nutrient enrichment, both from phosphorus and nitrogen. And phosphorus eutrophication is still a major problem in Northern Ireland. So you can see this graph on the right. We had the introduction of the phosphorus use in agriculture regulation in 2006, and this contributed to a reduction in phosphorus in Northern Ireland's waterways. But any improvements have since been lost, with increases in phosphorus measured in the NI waterways since 2012. So phosphorus pollution is still a major issue in Northern Ireland, and agriculture is still a major contributor of phosphorus entering freshwater in Northern Ireland. So is feed the problem or solution? Well, you could argue both. Historically, dairy cows have been overfed phosphorus due to this perception of a high requirement for dairy cows for milk production, but also due to a sort of added safety margin. So are we still feeding diets too high in phosphorus? As mentioned, this increase in production from systems is primarily driven by concentrate use. So we are feeding more concentrates, which are still high in phosphorus. Also, there's a move to include more byproducts in concentrates to try and decrease the human edible portion of the concentrate, but also to reduce costs. But byproducts are high in phosphorus. But feed is also the solution. So by improving feed efficiency, so lowering the phosphorus content in the diet, it will enable cows to utilize it more efficiently and lower phosphorus excreted into the environment. We also need to gain a better understanding of phosphorus content in both forages and concentrates. So what is the phosphorus content of your grasses or silages? And are we considering phosphorus content of the total diet? When we look at lowering the diet phosphorus content, there was a major study done in AFBI almost 20 years ago now that looked at lowering phosphorus content of diets. And this was a long-term study that followed 100 first lactation dairy heifers over a 4-year period. And in that study, we were able to reduce the total diet phosphorus content by 20%. and we see no negative effect on cow performance or health, and achieved a 45% reduction in phosphorus level that was lost in manure with no long-term impacts on cow bone density. So it's about building the confidence to reduce our phosphorus levels or remove that safety margin that will help reduce our phosphorus excretion into the environment. So at the moment, your industry standard dairy concentrate might be sitting around 5.5 to 6 grams per kilogram dairy matter of phosphorus. But should we be targeting a P content of around 4.5 or 4.4, which was used in the AFBI study? Sorry here, there we go. So when we look at nitrogen losses into the environment, so dairy cows are not efficient at utilising dietary nitrogen. Typically only 25 to 30% of nitrogen consumed is actually converted into milk nitrogen. And the theoretical maximum efficiency at which dairy cows can utilise nitrogen has been predicted to be about 45%. And while that's still not a high value, there's considerable room for improvement. So excess dietary nitrogen is excreted primarily in urine and a small proportion in feces. And part of this nitrogen excreted into manure is of course recycled back to the plant when manure or slurry is applied, but there are significant losses that occur in the environment. So nitrogen is lost as ammonia and nitrous oxide, which is a potent greenhouse gas from manure. So initially when the urine and feces is mixed, so it's released from animal housing, but also during storage and during application. And this is primarily as nitrous oxide at this point, and then nitrates enter our waterways. And some recent stats suggest that in 2021, of the UK ammonia emissions from agriculture, 86% came from livestock, with 50% of those ammonia emissions coming from cattle. And that was split about 25% from dairy and 25% from other cattle. So what can we do to reduce our impact? So there's a major four-year project at AFBI that's looking at dietary nitrogen content to reduce the environmental impact of dairying. And in the first year of that project, we looked at reducing dietary crude protein content from 17 to 15% in early lactation, so up to 180 days of milk. And in that study, we see no difference in performance in early lactation and improved nitrogen use efficiency when we reduce dietary crude protein content. So moving from the 17 to 15% crude protein diet, on average, there was a 10% improvement in nitrogen use efficiency. Now, the caveat to this is that we then followed these groups of cows on into later lactation and moved half of the cows in each treatment onto a lower dietary crude protein content of 14%. And we did see a drop in performance in cows offered 14 and 15% crude protein in later lactation. But the nitrogen use efficiency of those cows was improved with a lower dietary crude protein content. So in the second year of that project, we looked at diets containing 17, 15.5 and 14% total diet crude protein. And we looked at the effect of reducing dietary crude protein on ammonia emitted from manure. So this was part of some digestibility studies where we were able to collect urine and feces separately. And that allowed us to mix the manure and measure the gas emitted over a 5-week period. So reducing the total diet crude protein from 17%, which you can see in this graph on the right is the red line, down to 14%, which is the green line on the graph. That reduced the ammonia emitted from manure by about 64%, with the ammonia emitted from the 15.5% diet, which is the blue line there, intermediate. And as expected, the ammonia emitted is greatest after the initial mixing of urine and feces and decreases over time. So, as a target, if you can work closely with a nutritionist, have some feed analysis and performance information to input into a ration software, you can lower your dietary crude protein content to about 15%. And the reason we're saying here about precision formulation is that in all diets in these studies, we aim to meet the MP requirements, which is the metabolizable protein level. And if you can formulate to meet MP requirements, then you can drop your crude protein levels. In these studies, we also regularly monitor diet crude protein content of the silages and the concentrate. So really information is key. But as is industry standard, there's no reason why crude protein content couldn't be lowered to around 16% without a loss in performance. Another area of focus is the sustainability around concentrate use and producing dairy from human edible feedstuff. So the human population is projected to reach 9 billion by 2050, and there's an increasing challenge to meet food demands. And a significant portion of human edible food produced, looking at cereals and soya, is fed to livestock. But is this really sustainable, especially for ruminants? And what would happen if we removed or partially removed some of these human edible feeds from dairy cow diets? So a major project has started in the last year called SUSMilk, and it aims to look at the impact of reducing human edible feeds in dairy cow diets. And in studies so far, we've been able to reduce the human edible component from about 54% to about 18% of the diet. So what we're also looking at is whether these responses differ between higher and lower yielding cows when the cereal proportion is lowered in the concentrate, and also what is the impact of silage quality on decreasing cereal portion in the diet. So considering concentrates and economic performance then, there was an on-farm study conducted at AFBI in 2018, and it focused on investigating feed to yield systems. So there were 30 farms which were followed over the winter feeding period. So silages and concentrates were sampled on a number of occasions, and individual cow intakes were estimated. Milk production and composition were obtained from the milk recording systems. So the higher producing herds were feeding more concentrates. But if you take a look at the graph there on the left, as concentrate intakes increased from 68 kilos a day up to 16 to 18 kilos a day, milk fat dropped. So farms were overfeeding concentrate. And when looking at the economics of this, the drop in milk solids negatively impacted milk bonus. And although this graph on the right here doesn't have milk price per se, the effect is relatively similar because the bonus on milk solids says relatively static. So in short, the increase in milk yield due to high concentrate feeding can suppress milk solids and reduce profitability. So we focused on concentrate feeding so far, but forage component is also important. Grass silage is a key component in the dairy cow diet over the winter, but increasingly all year round as more farms move to confined systems. And producing high quality silage offers opportunity to reduce the use of concentrates so we can lower the environmental impact and improve profitability. So we've just completed a 4-year project here at AFBI that looked at improving silage quality. And one aspect of that was looking at the number of harvests. So looking at silage yield and quality, we actually looked compared a 3 versus 4 cut system, and the resulting silages were offered consecutively to fresh calved cows for 25 weeks. So when we're looking at the silage yield and quality, silage yield was lower for the 4 cut system with a higher cost of production as there was that extra harvest, but silage from the 4 cut system had a higher ME and crude protein content. So harvesting more frequently improved quality but reduced dry matter yield per hectare. But when looking at this from the performance side, better quality silage from the 4 cut system increased cow performance. So the cows offered silage from the 4 cut system had a greater silage intake, similar concentrate intake, but produced more milk. And it's this greater milk solids yield that and the increase in production that offsets the increased cost of production of the four-cut system, so there was a greater margin over feed. So it's well known that improving silage quality will improve performance and in turn profitability. And a review that was conducted a number of years ago suggests that every 1% increase in D value can increase intakes by 0.2 kilos and milk yield by 0.3 kilos. And if you look at those top producing herds, they often use less concentrates and have more reliance on producing milk from forage and are more profitable. So improving silage quality will allow for more milk produced from forage and a reduction in concentrate use, which will lower the environmental impact and improve sustainability. So some key take-home messages then. There's an increasing pressure in agriculture and the dairy industry to reduce your environmental impact of production and improve sustainability. But we want to maintain productivity and improve our efficiency. So with these challenges come opportunities. So when we looked earlier then at precision feeding, so there's opportunities to lower the protein content and feed to metabolizable protein requirements to improve our nitrogen use efficiency. There's also opportunities to reduce our phosphorus contents of diets and include some byproducts to improve sustainability. We also need to focus on improving forage quality to really produce more milk from forage rather than concentrate. So thank you for your attention, and I'll pass you back to Jason.
Thank you very much, Anna, for that presentation. And we're moving on now to our farm video for this evening. At each of these webinars, we're bringing you case studies from farms across the province we work with as part of our Beacon Grass Check and EIP and other projects. These farmers are integral and a vital part of our work, and we couldn't deliver our research and innovation programs without their help and support. This evening's video features Thomas Steele, a well-known dairy farmer who farms in partnership with his brother and parents near Cristobal on the Ards Peninsula. So we'll start the video now.
I'm Thomas Steele. I farm here in Cristobal, County Down, in partnership with my parents and my brother. We're currently milking just shy of 600 cows on farm, with all young stock kept for replacements. We operate a high input, high output system, and cows are housed 365 days a year. Several years ago, we were involved in an AFBI project involving low protein, and it was just one of those things that I suppose at the time we were just looking maybe trying something different, and I'd sort of heard a few good reports about it, and it's just something we're quite interested in at the time. We run like 2 different batches, and we're looking sort of what we'd been doing before, and then a low protein batch. So basically we were restricting the protein in that first period, and then just slowly ramping the cows up then afterwards. What we probably seen initially were cows were a wee bit slower to peak. They didn't maybe peak just as quickly, but what we found was later in lactation, they continued milking on and we didn't get a sudden drop off. So what we maybe lost initially, we more than gained it in later lactation cows. It actually worked very well with us as well, because we're 3 times a day milking here on the farm, and we would tend to find with milking those low yielding cows 3 times, we were getting the lactation was extended and more milk was being produced. Looking at the way prices have gone, etc., we're always looking, homegrown forages are the cheapest. We have, over the past few years, we've increased our maize acreage, and I said we try to grow a lot of forage maize, again for starch value. We also have started growing lucerne, and again we've found that has reduced the amount of bought-in protein that we need on farm here. So, and also in our silage operation, again trying to make as good high quality forages as we can to sort of reduce the amount of bought-in concentrates. On the farm here, our ground was quite early, and we can actually get away with making 4 to 5 cuts of silage per year. First cut will normally start anytime sort of end of April, start of May, and then we're consistently cutting about every sort of 5 or 6 weeks after that. Again, that high quality silage is sort of the key to our system here, and we need that consistent silage to maintain high levels of milk production. When we initially, I suppose, went to the multi-cut system, what we have noticed, I suppose, a big difference is just we don't really end up with such a bad cut of silage. All our cuts are the same, and for our cows here, we need the same ration 365 days a year, and our first cut, second cut, third cut, there's not a massive difference in them quality-wise, and I say we can sort of feed those to all our stock on the farm here. So I say consistency would be a lot more uniform.
Thank you, Jason and Thomas, for that video. Now I'd like to introduce Omar Cristobal Carballo, who is going to take us through some of the work in AFBI looking at methane inhibition. So Omar, over to you.
Thank you, Elizabeth. Good evening, everyone. So can you see my presentation?
Yes, that's
Perfect.
good, Omar. Thanks. Yeah.
Excellent. Hi, everyone. Today, the title of my presentation is Methane Emissions and Mitigation Strategies in the Northern Ireland Dairy Sector. So methane is the second most important greenhouse gas after CO2. So then how is this methane produced in the ruminant? Well, ruminant, as everybody knows, we know that they get their nutrients from the feed that is fermented in the rumen. So in the figure, you will see that during the rumen fermentation process, the methane is naturally produced by the microbiome that the rumen harbors. The production of methane represents an energy loss between 6 and 12% of the gross energy that the animal consumes. So therefore, methane is a fermentation waste product to the ruminant. So there are several strategies to reduce methane emissions. We can group them into 3 main categories, as we can see in the figure. So the first one is basically based on the management, either for the animals or the feed. These include practices like feeding processing, increases in feeding level, genetic selection, increases forage quality, among others. So the second category in this figure is the diet formulation. So this includes decreasing the forage to concentrate ratio or use of forages rich in tannins or including fats or oil seeds. And the last category here is the rumen manipulation. So these are basically targeting directly or indirectly the rumen microbiome. Among these strategies, we have the use of additives, electric sinks, defaunation, and inclusive vaccination. So listed on the left, there are some of the strategies that we have studied or are currently testing at AFBI. So the first one, the feed composition. Well, in this table, you will see that how different components in the diet might affect the animal performance and the methane production. Let's use the 2 examples that are circled in the table. So either the increase or decrease of these 2 components might affect the diet. Let's assume that we increase the amount of one of them in the diet. Saying this, increasing the amount of fiber in the diet might result in an increase of methane per kilo of dry matter intake. On the other hand, if we increase the starch in the diet, we can reduce the methane produced in the rumen per kilo of dry matter intake. So now, talking about the feed intake. In the left, you will see the figure how the feed intake is highly correlated to, the feed intake is highly correlated to the methane production. Well, the graph on the right shows that increases in the feeder level after maintenance requirements can decrease the methane emissions. Therefore, saying this, increasing the feeding level from improved feed availability and quality results in greater animal productivity. This means that there is a lesser production of methane emitted associated to the animal feed intake per unit of milk or of feed intake. So the second approach is improve the diet quality. Well, here we have an example of how feeding high-quality silages in the TMR of a lactating dairy cow can decrease up to 9% methane production per kilo of milk produced when compared to cows consuming a TMR with low silage quality. Saying this, well, improved feeding quality results in an increased feed intake and milk production, which decreases the methane emitted per unit of milk produced by the animal. Methane reducing additives. Well, at AFBI and in collaboration with Queen's University, as well as national and international partners, we have studied different strategies to reduce methane emissions. Among them, we have the use of omega-3 oils, plants rich in tannins, red algae like Asparagoxy, taxiformis, halides, and other synthetic compounds like trinol P. This is an example of a pilot study that we realized in collaboration with some of our partners like Brook Hall, Foley, or Queen's University, using steers grazing in some plants that are rich in tannins, such as willow. Our results, or preliminary results, show that steers grazing plants rich in tannins produce 20% less methane compared to those animals grazing only raygrass. Now, this is an example of a diet where we supplemented omega-3 oils. In this sheep model, we observed that increasing the level of omega-3 oil from 0 to up to 1.6% of the dry matter in the dry matter basis, the diet we can reduce methane when on around 22%, whilst the methane per kilo of dry matter intake is reduced up to 20%. All these reduction effects without affecting the feed digestibility. This is another example of a study, one of the earliest studies using red algae or Asparagoxy taxiformis. This was done in steers. The results from these studies or scientist studies showed that the inclusion of 0.25 or 0.50% in the dry matter basis of Asparagoxys reduced methane emissions significantly in either for methane production per kilo of dry matter or per kilo of milk produced around 70%. So evaluations of this red algae supplemented at different doses in the TMR diet of finalizing steers are currently taking place at AFBI. Something important here that I want to highlight or to mention is that these results, well, the effectiveness of methane inhibitors can vary depending on different factors, such as the dose, the animal type, the diet composition, management practices, including the way we measure the methane emitted by these animals. This is an example of a synthetic compound called trinoxypropanol, or nowadays, this commercial name called Bovaer. This shows how using inhibitors eaten in the rivers on the concentrate might have an effect on the lactation, on the milk production. Might have an effect on the dry matter intake. Didn't have an effect on dry matter intake, but could reduce methane up to 20% without affecting the dry matter intake or the milk production. So some of the ongoing research projects at AFBI to reduce and tame methane emissions in ruminants. Well, we have several projects going on at the moment. So some of them are in vitro screening of different food byproducts, as well as inhibitors, methane inhibitors. We are also evaluating the effect of multiple species source on methane emissions and performance. We are testing different food byproducts in some animal experiments to see what's the effect on methane emissions. We are currently also evaluating the use of novel methane inhibitors in the diet of some lambs. Among of other studies that we are that are taking place at AFBI, we have the manipulation of the ruminant microbiome during the early life, in a matter of trying to program this the microbial colonization of the rumen. And finally, we are evaluating new technologies and techniques to measure methane emissions. So some take-home messages. Well, there exist several nutritional strategies to increase feed intake and animal production while reducing methane emissions. There is a range of direct methane dietary inhibitors that have been developed. However, as I mentioned before, the effectiveness to inhibit methane can vary depending on animal, dietary, and management factors. The development of technologies to reduce methane emissions in grazing ruminants definitely is a challenge, but there are some signs of promise. At AFBI, also in collaboration with Queen's and national and international partners, we are currently working on trying to close those research gaps to mitigate entire methane emissions. But not only that, so if you remember at the beginning of my talk, I mentioned that methane is a waste product of feed fermentation. Therefore, this scientific community, including AFBI, of course, we are putting a lot of effort on redirecting and turning methane emissions into enhanced animal performance. And with this, I want to thank you and thank you for your attention.
Thank you, Omar. Okay, Omar, thank you very much indeed. I'll just do the next one. Okay then, thank you, Omar, for that, and thanks to all our speakers. Dairy cow nutrition is a large and a complex topic. Getting it right has considerable benefits for livestock performance, farm profitability, and environmental impact. Thomas Steele explained how he used lower protein diets at the start of the lactation to minimize negative energy balance. While this means cows are slower to reach their peak, there is no significant overall lactation reduction in overall lactation. Research has demonstrated significant reductions in ammonia emissions by adopting this approach. Thomas also emphasized the importance of high-quality size to ensure cow performance. This was also proven by size research featured by Anna, with her higher quality size resulting in a margin improvement of 32 pence per cow per day. For a 200 cow herd with a 6-month winter, that is an increased margin of almost £12,000. Omar's work also showed how better silage quality reduced in a 9% reduction in methane emissions. Thomas is also growing lucerne, which has the added benefit of being a good source of protein and high quality fiber, as well as not requiring manufactured end fertilizer. What we feed our cows also has environmental implications, and Anna Lavery discussed how we can lower phosphorus content of our rations without negatively affecting cow health and performance. Your dairy nutritionist is a very important part of your farm team and should, of course, be consulted before you make any significant changes to any diets. Looking to the future, there is increased pressure to reduce the amount of human edible feed in livestock diets and also to further reduce the methane emissions of livestock. Ongoing work at AFBI and Queen's is addressing these issues, and DERA will shortly be launching a new livestock dietary emissions challenge fund, specifically targeted at the dairy sector, which will enable the feed industry, processors, farmers and academics to examine some of the practicalities of feeding these additives on farm. Of course, we have to recognise that this winter will be particularly challenging for dairy cow nutrition, given that many of the silages will be of suboptimal quality and the current beef milk price feed price ratio. This issue was discussed at our recent AgriSearch webinar, and recording of this can be viewed at our website and YouTube channel and contains a lot of very useful information for dealing with the current situation. There are also a number of publications on dairy cow nutrition research, which can be downloaded from the AgriSearch website, featuring many of the topics that were featured tonight. And that's it for me. And I will now hand over to William to chair the Q&A.
Sorry, folks, I was struggling with the technology there for a second, but hopefully everybody can hear me now. So thank you to all our speakers, some very interesting topics and information there. We have some questions in the Q&A box, and the first one is from Jonathan Smith, and he's querying, I suspect this is directed at you, Anna. He's querying the reduction of yield in a multi-cut silage system. He's of the opinion that while yield per cut would be lower, the overall tons should be higher, and the energy should be higher as well. So I just like to hear your response to that.
Yeah, thanks. We did see a reduction in yield with the 4-cut system, but in this particular study, we have to take in, I suppose, the year effect. So this was based on a single year. So we had some drier conditions between different cuts, because the cuts on the 4-cut system and the 3-cut system were slightly different. Also, the nitrogen that was applied was the same for both treatments. So usually with the 4-cut system, you'd be applying slightly more nitrogen, but what we had based it on was the recommendations, the RB209. So that probably explains why there's slightly lower yield then from the 4-cut system. With regards to the energy, we did see that the first harvest in the 4-cut system was considerably higher and sort of decreased as we went along, which you'd expect, but the values there again are weighted for the whole experimental period. So we had a lower energy grass in the very last 4th cut, which really brought that sort of 4-cut average down. So that's that.
Thanks, Anna, for that. The next question I have here is from Michael Woodrow, and he is asking, why at AFBI are we still looking at crude protein in diets? Should you not be looking at balancing diets on the various protein fractions, including amino acids? And he says we can do this in the nutrition software now, no problem. So, Anna, do you want to respond again there?
Yeah, of course. So we are. I mentioned that all the diets, although we were looking at a reduction in total diet crude protein, we were basing those diets on meeting metabolizable protein requirements. The reason we're still focusing slightly on crude protein content is that this is still what is practically sort of talked about on farms. So it is still a good thing to consider. We are working with industry partners on this, so we are aware, like using that software, looking at the different protein fractions as part of these studies. But we feel that the amount of information, so like I mentioned, we were analysing silages weekly, concentrates monthly throughout the duration of the study, and tweaking diets if needs be. So that kind of information necessarily wouldn't be available on farm. So that's why still looking at total diet crude protein we felt was important to have a practical application. When looking at amino acids, that isn't something we've looked at in this particular project, but it is something we're considering in future work. Yeah.
Yep. Thanks again. And we have a question now from someone who would rather not be known. And this person asks, do rumen protected methionine or lysine have a role to play in reducing overall crude protein level? And if so, what research is ongoing on inclusion rates and effect on profitability? So is that you again best placed to?
Yeah, it probably is. No, you're grand. Yeah, we are looking at so the second year of the study, it didn't look at particular rumen protected methionine or lysine as such, but it did look at different ingredient bypass proteins and ingredients that could be used. But yes, they do have a place in reducing overall crude protein content, but as such, particular amino acids haven't been looked at from ourselves. And again, yes, it's important to really look at these inclusion rates and including these products and whether they'll still allow farms to be profitable.
Right. Thanks for that. You can have a rest day, Anna, and we're going to we have a question here for Omar. And are methane inhibitors specific to cattle, or are they effective across all ruminant species?
Yeah, well, the quick answer to this is no, they are not specific to cattle. So many of these methane inhibitors can be used across different ruminant species. Yeah, and well, I showed some examples indicating the model, but those models are not specific, so they can be used either in sheep as well as in buffaloes or in cattle. So there is no problem to be used across different species, ruminant species.
Yeah, and this question for you also, Omar, from myself actually. You mentioned there willows that are rich in tannins being included. Like, does that have a performance effect on the livestock, or is it at a level that doesn't affect performance?
I mean, at the moment, the pilot study that we conducted did not have a significant effect on performance. However, well, the intake of high amounts of tannins can reduce feed intake, and that can potentially reduce either milk production or growth, but it depends on the amount of tannins that the animal gets in the diet. So, but it could affect performance, but depending on the level of intake of tannins. Yeah.
Thank you. And we're back to you now, Anna, and we're back onto this 3-cut or 4-cut silage system. And there's a query here, around the cost of 4 cuts versus 3 cuts.
Yeah, so we included the cost there per ton of dry matter. So the 4-cut system was around 150 pounds per ton of dry matter, and then our 3-cut system was around 125 pounds, but that's based on 2021 costs. So that'll vary year to year on different parameters.
Yeah. Mm-hmm. Thanks for that. And this may well be our last question because our time's coming to an end. But this question's from David Wright, and he understands the logic of reducing P in diets, but he says the research that's being quoted here is 20 years old, and genetics have moved on a lot since then, and there seems to be more P deficiency on farms than previously was. Is there any evidence around this, or is this a factor or fiction?
Well, yes, genetics have moved on, but the principle is still the same, that the cows don't utilize phosphorus very well. It's only about 30%, similar to your nitrogen use efficiency. So at the levels that we are feeding, that cow can't utilize that phosphorus anymore. It is just excreted. And there's no added benefit in performance or fertility. I know there was a lot of research a good while ago that sort of focused on lower P diets. There might have been an impact on fertility, but we're talking about deficiencies at like 0.25% of the diet. The levels that we're feeding, we're still overfeeding. So recommendations are usually between 0.3 to 0.339% of the total diet is phosphorus, and we're still feeding well above that. So although genetics have moved on, the biology behind using the phosphorus use of the animal hasn't. We're still overfeeding.
Yeah, lots of room for movement yet then.
Yeah.
So I think this really will be the last question now. This one's from Robert Martin, and he's stating clover is probably the easier adaptable tack for the farmer is in the breeding of. Is that a simpler way of reducing methane, including clover in the diet?
Well, it can potentially reduce, improving the digestibility of the diet, but it's not the absolute answer to reach the targets that we are basically looking at for 2015. So this could be part of it. Could be the breeding of our forage species, but also the management of this, as well as the selection of breeding of animals. So there is not the absolute answer. It's part of the answer, but there might be other components also to add on the equations to reach the targets on reducing methane emissions to the targets that we have for the net zero ammonia. Something important that I forgot to mention is that the inhibitors that we have been using at AFBI as in the different experiments, they might require license or approval to be used in different species or in animals. So there are some of them are still under testing. So yeah, so that's my question, my answer. Sorry.
Yeah, thank you, Omar. And this is the third last question now we're on. So,
sorry, William, I was going to just make a comment about the breeding of forages, if you don't mind, for Robert there. The clover, the inclusion of clover on the sward mainly reduces nitrous oxide due to less nitrogen fertilizer being needed on the sward. So it's the nitrous oxide greenhouse gas that has the main impact when you introduce a clover. And breeding for clovers to increase that nitrogen fixation agenda will further reduce that. The breeding of ryegrass then, again, is more about a nutrient efficiency agenda, increasing the digestibility of ryegrass, which we do breed for, will have an impact on methane, but it's not going to have as material an impact on methane as the likes of your inhibitors. So breeding for forages going forward is probably more around resilient swards for maintaining yield and deeper rooting and drought resistance and nutrient efficiency from a nitrogen and phosphorus perspective and increasing digestibility. But it'll not necessarily, forages in the form of ryegrass, not necessarily will reduce methane as a direct impact, if you understand me.
Thank you for that, Elizabeth. And this really is the last question now. And the question is, will methane inhibitors change the pH of the rumen and therefore the slurry reducing ammonia emissions?
So most of the methane inhibitors that we have been testing or been tested, most of them, the mode of action is after some time they degrade in the rumen or are metabolized by the bacteria. So there are no significant changes in the ruminal pH. So therefore, I must say that the potential impact after being or in the feces could be minimal. So, however, there's research on that regards on looking at the effect after being excreted on the potentially methane emissions or fermentation of these slurries. But at the moment, such as the example of Trinop, so Trinop P is degraded in the rumen, as well as the bromoform that is in the Asparagopsis is also degraded in the rumen. So there is not like an after effect on this on the slurries.
Thank you for that, and indeed thank you to Jason, Omar, Anna, and Elizabeth for their contributions tonight, and thank you for all that have listened in and have asked questions. Hopefully everyone has found it informative and useful. Just to flag up next Tuesday night's webinar, and it is on nutrient management in grassland, and will be on next Tuesday night at 8 p.m. again. So thank you again for listening in, and good night.